Okay, so this is the first example using NGon. First, I would like to explain what does it mean by NGon. Okay, the first example here, we have a set of curves. If we take a look of the curve using this text panel, you see there are 7 polyline curves. So each polyline is one of these hexagons. So totally there are 7 hexagons. Okay, and then we use this component from NGon. You can take a look. So it is one component from NGon, and from this group of components. I think this group of components are for creating different kind of NGon. So after you use this component and the output with the input with a set of polylines, more precisely, they should be closed the polyline. So this polyline will enclose some certain area of some shape, and then it will create a mesh. Okay, and you can display it. Okay, can you tell me what's wrong with this mesh? We send out this mesh as a text, and you see that this mesh consists of 24 vertices and 28 faces. But what you see here, what's wrong with it? Someone tell me.
Because the vertices
Yeah.
overlap.
Okay, that's one possibility. And some other things? Have you count the vertices? Not so easy. Okay, anyway. Should be, let me think. 31, I guess. So 7 are missing. Okay. How about the faces? Based on what you see here, how many faces are there for this mesh? 7. But in this text panel, it says there are 28 faces. Why? Okay, if we somehow deconstruct the mesh, okay, we go to mesh, deconstruct mesh. And then we can check how many vertices are there. 24. Okay, how many faces are there? 28. So it is correct. But can we list these faces? 28 faces. Okay, it says there are 28 faces, but when you look at it, you see only 7. What's wrong with it? When you list these faces, okay, what does it mean by T? What does T represent? What kind of faces can we have in a mesh? 2 options, right? Triangle and quadrangle. So if it is quadrangle, then here, when you list it in the text panel, it should start with Q. And when it's triangle, it starts with T. Okay, and you see the vertices of this triangle is number 17, number 20, and number 16. So there are only 3 vertices. But what we see here are hexagons. So if we want to guess why it says 28 faces, it's because maybe the reason is that every hexagon consists of some triangles, right? And the problem is that we don't see the boundary of these triangles. Okay? So from here, we can understand why this plugin package is called NGon. GON is kind of abbreviation of polygon. Okay? Poly means many. So polygon is many-sided surfaces. Okay? And NGon means you can have variable sided shape for the mesh faces. Okay. With Grasshopper, the original Grasshopper mesh setup, you can only have triangles and quadrangles. But somehow, internal data structure of Grasshopper mesh, it actually allows many-sided polygons, okay, including hexagon, and of course also pentagon. Okay, of course there is a limit. I mean, there should be the largest number of n it can be, but I would say it can be very large, so you don't even need to know the limitation. Okay, so NGon with this plugin, we can define meshes with surfaces which has more than 4 edges. So one very interesting thing is that somehow it still recognized, Grasshopper still recognized this data structure as the regular mesh. Okay, but somehow in order to use this plugin package, we need to understand the behind, what is it behind this whole thing. So when we deconstruct a mesh created by this NGon component called from polyline, which means it can create NGon mesh from a set of closed polyline, okay? And the definition of vertices and faces will be based on the polyline you provide. If you provide hexagon, then the surfaces, the faces of this mesh may consist of hexagon. Okay. But somehow it is still a legal Grasshopper mesh. So you use Grasshopper component to deconstruct it. You find out what indeed in the internal structure of a Grasshopper mesh. It consists of 28 triangles. Okay? If we want to return this mesh definition back to the original Grasshopper definition, then we can use an NGon component called clear. Okay, so it is here, clear, which means to clear the NGon structure of the mesh. Then we find this. Okay, so for every hexagon, for example, like this one, it is divided into 1, 2, 3, 4 triangles. And for the 1, 2, 3, 4, okay, also the same. Okay, so for each of these hexagon, it is divided into 4, so 4 times 7 is 28. Okay, but somehow in this mesh created by NGon component, all these subdivisions of triangular subdivisions are hidden inside the data structure. Okay, and somehow we can explicate, we can turn this subdivision explicit by using this clear component. Okay, so that we can bring this structure back to original Grasshopper mesh construction. Okay, so I think this example is only an introduction to NGon and the method for creating NGon through curves, polyline curves, or breadths. Okay, so this is the first example. Second example, one closed polyline. Okay, I don't know this is how many edges are there for this polyline, but this is a closed polyline. Let's show it. Polyline curve, okay, and it has to be closed. And this merge the two lists of curves. This curve component consists of two, and if you rotate the perspective view, then you see that it is in the three-dimensional space. Okay, and one thing I want you to be aware of is that one of the polyline, this one, the top one, is not planar. Okay, I think the other two are planar. When you rotate to the right angle, the view angle, then you see that they are plane. Okay, but this one, no matter how you rotate your view, you can never make it like a plane. And then you merge these two component, curve component. Sorry. Then you see that there are three curves. Okay, and then you use another NGon component. Okay, so it is from the same group, and this one is called create mesh from polyline with holes. Okay, so when we look from the top view. Oh no, we should not look from the top view. Maybe look from the front view. Okay. It looks like that we have a large surface, and then we want to create two holes on it. But when you see from the perspective, you find that they are not on the same plane. And then when you use this from polyline with hole component, you get this mesh. How can you understand this mesh? Oh, actually, there's no holes. But if we display all of them, no. This one, okay? Somehow it tried to create a mesh that connect all these polylines. Although these polylines, they may not be planar, they are not on the same plane, and somehow it creates a reasonable mesh to connect all these polylines. Okay. And I think the example, they don't have any holes in it, but if you put this polyline, enclosed polyline, on the same plane, I think they will appear like a hole on the surface. Okay, and why here there is a very strange thing. If we choose both of this, you see this one, this polyline, this is the one which is not planar, you see. Okay, if we try to make it planar as good as possible, then here this part is planar, but this one is not planar. So when it creates a mesh, it somehow interpreted it as a flying face like this. Okay, so this is another way for you to create NGon. Okay, and then another way to create NGon, mesh with NGons from breadths. Now we have a breadth like this. So each of these pentagon is a surface, is a pentagonal surface. And then this break consists of 12 pentagonal surfaces. So it is a dodecahedron. Okay? And we can use this component, which is also from NGon. Okay. And then you get this mesh. Okay. We check the faces. Okay. This time there are 32 vertices. 32 vertices and 60 faces. Okay, and here we can use the clear component to figure out the subdivisions of each of these faces. So it's not so easy to see, but we can still see it. Let me see if I preview it. Still difficult to see. Okay, anyway, give up. So you see each of these pentagon is further divided into 5 triangles. Okay, so originally, because it is dodecahedron, so it has 12 pentagons. And each pentagon becomes 5 triangles. So totally we have 60 triangles. Okay, with 32 vertices. Okay, and this one. This one is a mesh, a regular grasshopper mesh. It has 29 vertices, 27 triangles. I think they are all triangles. But if you create this, you use this mesh to create an NGon, what it does is it regards it as one face with 29 edges, I think. 29 edges? No. Yeah, I think 29 edges. And when you show this, the internal structure is still the same. Okay, but when you check the vertices, it is an index list. Oh, sorry, not this one. It is an index list. Somehow it is the same order. And then this is the boundary of the mesh. Okay, and this indices you can get it from the mesh. So if you deconstruct the mesh, then you get a list of points, right? And then you use this indices as indices to retrieve the points. So we go to set nth. You get all these points, and I think these points are ordered like what you see here in the list. And it happens that the order, the sequence is exactly the same. So it is not changed. But somehow, let me see. Here, you have only one mesh. Okay. So there's another way. We can create a mesh to an NGon mesh using from mesh component. Okay, the shape remains the same, but somehow the structure is changed. When the faces are on the same plane, and if they are connected, then these triangles will be joined together to make an NGon face. Okay, and this one, get mesh NGon polylines. So this is NGon, okay, created by one of the component we have just explained, and then we can get the polyline from that represent this NGon. So when we have an NGon mesh, we can switch this NGon representation from a mesh representation to its polyline representation. So after this component, you get a set of polylines. So actually, what you can do is you can use this set of polyline to bring them back into an NGon mesh. So where is NGon? This is NGon. Okay, and then NGons from polyline. So using this component, you make it back to an NGon mesh. Okay, and this is a way to preview an NGon. Okay, it has some interesting feature. Sometimes it is very useful for visualization. So we have a mesh, and then you use this NGon preview. You can define the color on one side and another color for the other side. So this is the front side, this is the back. So if you turn it, see, this is the color of the back side or the real side. But you turn the view to the front, then it is gray. If you turn here, then it is orange. We can change it to green if you like, or to red, okay, black to yellow. Okay, so using this, you can define two-sided mesh, and you define the front side and the back side. And what is this? Line weight. Oh, so you can have different line weight, maybe. Doesn't like it? No, this is not number. This is not number, so I cannot use number. But what is it? Let me extract parameters. What is this? Line weight. This is a different construction. I can set color. This is strange. So I make it cyan. Okay, why they call it line weight? I don't guess. I don't get it. But somehow you can set color on it. Okay, so here you see the text panel 0, 255, 255. So RGB, it consists of green and blue. So it is a cyan color. Okay, so with this you can define the way to preview your setting. Okay, so